out how you would read that out loud. Can someone read that out loud to me? What does that statement say? The... Okay, hold on, go. Yes, the limit of f of x as x goes to 2 is 5. That's what it says out loud. Is it possible...
Is 5 being the y value?
Yes, that's correct. 5 is an output. X going to 2 is an input. So as you approach 2 from both sides, the output goes to 5. So as you... And this is the statement that we worked with before. As something gets arbitrarily... I'll make it bigger. Close to something else, then something gets arbitrarily close to something else. So I'm keeping this general. This is a phrase we talked about yesterday. It's just hard to type over the screen. And I'll make this bigger so you can read it. So as something gets arbitrarily close to something else gets arbitrarily close to something else. And what is that? We talked about this yesterday. As what gets arbitrarily close to what? What's the first thing? As x gets arbitrarily close to
the y value.
to 2, then f of x gets arbitrarily close to 5. That's what that statement says. Is it possible for f of 2 to be equal to 3? What do you think?
No.
Why not?
Because f of 2 should be equal to 5.
No, that's not what it says. It says the limit of f of x as x goes to 2 equals 5. Does that mean the function has to be 5 at 2?
No.
No. What this means is, here's the function. Do we have any idea what the function is? No. We know nothing about the function other than this one limit. Here's one thing it could be. So here is the function f of x. Here's the point 2, 5. If I'm a little tiny bug and I'm going along this line right here, if I'm moving this direction, if I go towards 2, here's 2, x equals 2. If I'm going towards x equals 2, what's the maximum height I'm going to get to? Or not get to, get arbitrarily close to what? 5. If I'm here and the bug is moving down like this, and I'm getting arbitrarily close to 2 from the right, what's the height it's going to get arbitrarily close to? 5. Does anything change if I fill in the function up here? No. Does anything change if I fill in the function down here? So I'll ask the question again. Can this be true? Yes. Absolutely. The function at the limit is totally irrelevant at this point. For limits, it doesn't matter what does the function even have to exist at 2? No. Can there just be an open dot there with these gone? Yeah, the limit is still 5. Can we fill this point in anywhere we want along this? Absolutely. We don't have to, we can. It doesn't change the limit being 5. Do we have any idea what this function looks like over here and over here? No, we don't. Does it matter? Not really. We're just being told it's a function. That's it. It's the same from both sides, and it is 3 right there. What about b here? That means approaching 3 from the left. You're approaching 3 from the left. What's the limit as you go to 3 from the left? 4. What's it as you approach 3 from the right? 2. Therefore, does the limit exist as you approach 3? No, it does not exist because the left-hand limit and the right-hand limit are different. The left-hand limit and the right-hand limits are different. The bug is traveling along here, it goes to 4. The bug is traveling along here, it goes to 2. Is 2 equal to 4?
No.
No. So therefore, the limit is said to not exist. What about here? What is f of 3?
I wrote y is 3.
Yeah, it's just 3. It's right there. There it is. So here it is. The left and right-hand limit can be different than the actual function value. Does the limit exist at 3?
Yeah.
No, it does not, because the left-hand limit and the right-hand limit are different. Left-hand limit is 4. The right-hand limit is 2. Is 2 equal to 4? It's not a trick question. 2 does not equal 4, so therefore the limit does not exist. For the limit to exist at a value, the left and right-hand limits need to be the same. If they're not the same, the limit is said not to exist. So this is our first way of proving a limit doesn't exist.
But if 3 is still, if that's still part of the function, I got it.
What's the limit as you go to 5?
4.
Really? Oh yeah, it is 4. I'm sorry. It is. I was looking at the wrong place. It is 5. Because look, as you go from the left and the right, what does it look like that point is? You're making an estimate. You don't know what the exact function is, so you have to make direct conclusions about what you're seeing. 4. Yeah, yes, it's 4. Thank you. Sorry. It is 4. Because this value is 4. Yeah. What about f of 5? Does not exist. Is the function defined at 5? No, there's an open dot. Doesn't exist. That's it. Totally it. Prior to, the two we did prior to this, we used our graphing calculators because we had no way to, we couldn't plug in the number, and we had no way of simplifying it. Sine x all over x, is there any good way to simplify that? No. You don't have a method of attacking that algebraically yet. So you use a calculator, you look at it, that one goes 1, the other one goes berserk, the limit doesn't exist. You can't really prove that, but we zoomed really far in and it kept on going berserk. You remember how we kept on zooming in and it was infinite oscillation? You're supposed to think about that last night. On this one, you might be cruising along, you might do the same thing. What do you always think of first when you're trying to evaluate a limit? What do you always try first?
Plug in.
No, you don't simplify first. What?
Plug in.
You plug in the number. Can you plug in 0 into this? Yeah, you can. What's cosine of 0? What's 1 over 10,000? 1 10,000th. So what's the limit here? 1 10,000th, right? So if you were cruising along, though, if you were cruising along and you decided, hey, you wanted to graph this thing, right? So like, you're cruising along, you're like, hey, let's graph this thing. So you did y equals, you got to turn it on first. Y equals, hey, there it is. X cubed plus cosine 5x divided by 10,000, right? If you were to zoom, let's say zoom, I don't know, standard, that's 6, right? It kind of looks like x cubed, right? And it really kind of should. It's going to look like x cubed. So if you just looked at that, what does it look like the limit is as you go to 0? Looks like you go to 0, right? The resolution on these calculators, good, medium, bad. Terrible, right? Pretty bad. So if you looked at this, you're like, ah, it's 0. Is it actually 0? No, we logicked it out beforehand so I could kind of set you up to see this. If you wanted to actually see what's going on, what should you do? Zoom really far into the origin, right? So if we choose the window here, let's go from, I don't know, -1 to 1. But we're going to change our y minimum. Let's go from, how about negative 5 divided by 10,000? And we'll go to 5 divided by 10,000. When we graph this thing, see what happens. Look at that. So does it actually cross at the origin there? You've played this magical game of graphing plugging it into your calculator. What's the second thing you always have to do if you're trying to generate a nice graph after you plug it into the y equals? What do you have to do next? What are we doing right now? Setting the window. Is that always easy? No, it's not. How many of you have played the magical fun game of what's the proper viewing window? You've all played that game before, right? You're trying to make it look, so you graph it and like you don't see anything. Just because you don't see anything, does that mean the graph is wrong? No, the graph might be over here and you're looking right here. Hey, look at this. Does that go through the origin? It really doesn't. What do we hope that value is for the y value right there? Let's just go right there. This is trace, so this is just estimating, right? Looks like 1 10,000th. Oh, you can't really see the y, can you?
Can't you go to like values and
Exactly. So this is the trace. It's not exact. What can we do instead? We can do,
Intersection?
there's intersection. So let's do that. Second calc, and you go to,
5.
can we use intersect in this case?
I really don't.
no, because
There's no second curve,
Oh, okay.
right? So instead, what can you do? Second calc, you do value, right? The x when x is 0. That is the exact same as doing the value from the main interface of the calculator, which we can do. But clip this in. So we look at this, and it really looks like it's 1 10,000th. We also know it should be because you can plug in 0, right? What you also can do, though, is if you just want to evaluate it really quickly, you go to y equals, sorry, we quit out of this. We go to vars, y vars, the function y1, and we want to evaluate it at what? 0. 1e, sorry, it's 1e is, oh, got to go that way and this way. There we go. There it is. So is that 1 10,000th?
Yes.
How do you know that's 1 10,000th? What is e -4 mean? 1 times 10 to the -4, right? So what is that? 1 times 10 to the -4, that's equal to 1, and you move it over 1, 2, 3, 4, like this. So that's equal to 1 over 10,000, because this is the tenths, 100, thousandth, this is the 10,000th place, right? So is that 1 over 10,000? Yes. Does that match what we think it should be? Yes. So just be very wary when you graph things. Zoom Sometimes it's really nice. Sometimes is it right? No, no. Be very careful. But what do you always check first? Plug in, then try to simplify, yeah. The y-axis is called a what of this function? A, bingo, yeah, a vertical asymptote, exactly. Have you seen asymptotes before? Hopefully, oh, hopefully. Vertical asymptotes, you see things going to infinity. Absolutely. So can that happen? Yes. You just need to understand what that means. And really the most important thing you can get here is infinity a number?
No.
No, no. So in this case, would you say the limit as x goes to 0, does it exist? No. From the left, it's one thing, and from the right, it's
The other
another thing.
Yeah,
Exactly.
They're not the same.
They're not the same. Not the same at all.